So for those cases where we have a lot of data, what we need to do is present the distribution of the data. And I will go through what is a distribution first, so that everyone is on board. So this is one type of a distribution. So these figures on the, so this is a survey questionnaire for a thing I made that you will encounter later. But this, I asked people who were reading a blog post of mine to guess how many percent of people who partook in an intervention, or how many of those could be considered average on for different outcome measures. And people were able to just guess the percentage. And we can see that 3 people answered 50%, one person answered 20%, 3 people answered 25%, and so forth. So the more people, the higher the bar. For some reason, 30, for example, was a popular choice, as was this one here. Anyway, what's usually done with the distributions is you present them in a histogram form. So these two are basically exactly the same. So here you have 3 people answering 50, and then if you take 3 here, you can see that, okay, 1, 2, 3. So this bar is now 3 people high, and this bar with the on 40%. So this is 4 people high, and so forth. So this is a histogram. And now when you think about what goes into the bar chart, there was a very nice campaign to raise awareness about these issues a while back. So these are bar charts that look exactly the same, but then when you do a what's called a box plot that shows the median and the or mean and also the outliers, you see that, hey, wait a minute, there are a lot of outliers in this one. But when you plot the histogram, you see something that reveals what the data is all about. So in this case, there are a lot of high observations and then a few people who are close to 0, and in this case, everyone is centered around 100, which produces the same plot. So this is called skewness, and it can crash many dreams for people who are using statistical methods that rely on normally distributed symmetrical data, because that's usually very much easier to work with. Oh yeah, and I also had a t-shirt about this when I was doing a presentation at the European Health Psychology Society's annual conference once. So that was a histogram, and a density plot is something that basically shows the form of the data where there are many observations. So in this case, this black line is a kernel density function, but it shows the density plot, and it's sort of the same as the histogram, but with histograms, you usually don't have this sort of a form where every where you have nice if you have continuous data, you could have a person saying 8.25 or 8.2563 or something like this. And each person, so this person might be the only one who answers exactly that option. So he gets sucked into one bar. And when you usually have to be very careful in choosing the bar width, these are now the same data. So, but this is what only just with coarser bar width. So, so both of these two peaks here, they go into this bar, and this peak here goes into, everything goes into this bar. So we say all of these observations are basically equal as far as we care. And people often don't choose the bar width very carefully, but you can find many ways of doing it more sensibly in your favorite search engine. But you usually have to just, or you may have to just go by trial and error. And this was something, so there's, you can also find this in your favorite search engine, or so these are called rain cloud plots, and they show the raw observations and the density plot. And I kind of grew fond of these, and I still like them because they show you the form of the distribution, and you can compare them with the different groups, and you still see the data. So, so this is each of these is a data point here. And let me walk you through this figure. So we had this intervention where we tried to enable more physical activity and less sitting time for students. And in vocational education, and we did this intervention, but before that we were looking into, like, okay, so what is their current physical activity? They wore a physical activity monitor for a week, and these are the results we got. And these diamonds here, they show you the centrality estimate. So this is so the center of the diamond is a mean, and the width of the diamond is the uncertainty around the and you see where the most of the observations are. In this case, there are many observations, so it's hard to see from the raw data, but this distribution shows you where most of the observations are. And then you have the actual data points below the density plot. And so these are boys, and these are girls. And with this data, I had a conundrum because it really looked like girls were more active. They were doing more physical activity than boys in this in our sample. And each of these is an educational track. So nursing, hotel, restaurant, catering, business administration, and information technology. So Why would this be? Because normally you see that boys are more active than girls. So when I made this plot, uh, I, I didn't see it immediately, but after staring at it for a while, I realized that yeah. So we have the smallest group here, and that is the IT, and it's mostly boys. And but it's also the lowest in physical activity. So if you look here, so it's the lowest active bunch. And then we have the highest active bunch, which is the practical nurse track, which is mostly girls. So when you clump all of these together, you see that actually that girls are more active than boys, whereas in each of these educational tracks, within the track, boys are more active than girls. This is an example of something called Simpson's paradox, if you're interested. You may also want to have a look at the blog post and the accompanying page.